Now see here, an electric dipole consists of charges plus 8 nanocoulomb and minus 8 nanocoulomb separated by 8 centimeter. It is in electric field strength of here 5 into 10 raised to power minus 5 Newton per coulomb. Calculate the work required to be done to turn the dipole end to end from theta 1 equal to 0. So, you have to turn the dipole actually from theta 1 to theta 2 and theta 1 is equal to 0 and theta 2 is equal to 180 degree. So, work done is, that is actually potential energy, that is your work is equal to Pe, and you can write here cos theta 1 minus cos theta 2, and P can be written Q into 2A into E cos theta 1 minus cos theta 2. So, we can write here 8 into 10 raised to power minus 9 coulomb, that is nanocoulomb. So, we can write 8 into 10 raised to power 9. 2A can be given 8 centimeters. So, we can write 8 into 10 raised to power minus 2 meter, and E is given to you 5 into 10 raised to power 5 into cos 0, that is 1 minus and minus 1. So, we can write here this is here minus 11 plus 5, that is minus 6. So, 320 into 10 raised to power minus 6 into 2. So, we can write here 3.2 into 10 raised to power minus 4 into 2 joule, that is here 6.4 into 10 raised to power minus 4 joule. So, this is the work done required to turn the diode to turn the dipole end to end from theta 1 equal to 0.